Hey everyone, and welcome. Today we're going to take a journey, a deep dive through all the layers of technology that make our digital world tick, from the absolute core of your computer all the way up into the cloud. So, it all kicks off with a really simple question. You double-click an icon to launch an app, and poof, it just appears. It feels like magic, right? But underneath that one simple action, there's this incredible, complex dance of technology happening. We're going to pull back that curtain. So, here's the game plan. We'll start at the very bottom, inside the kernel. Then we'll see what it's like to actually build an operating system from scratch. After that, we're taking a huge leap up into the cloud, checking out how modern software gets released, and then finally, we'll see how it all fits together. All right, let's get into it, starting at the most fundamental layer there is, the operating system's kernel. You can think of this as the absolute brain of the whole operation. Have you ever wondered how your computer can run like a dozen different apps at once when you only have so much physical memory or RAM? Well, it's all thanks to this super clever illusion called virtual memory. See, the OS tells every single app, hey, you've got this huge space to play in. But when an app needs something that isn't actually in the fast RAM at that moment, the OS just hits pause, triggers what's called a page fault, grabs the data from your slower hard drive, and zips it into RAM. The best part? The app has no idea any of this just happened. This little switcheroo is the secret to all modern multitasking. Okay, but with all that stuff happening at once, how does the OS stop total chaos? I mean, imagine two programs trying to write to the same file at the exact same time. It'd be a mess. Well, the OS acts like a traffic cop, and it uses different kinds of locks. A mutex is simple. It's like a key to a bathroom, only one in at a time. A spin lock is a bit more frantic, kind of like someone just rattling the doorknob over and over, hoping it opens. It's fast if you don't have to wait long. And then you have a read-write lock, which is more like a library. Lots of people can read a book at once, but only one person can check it out to write in the margins. And this quote, wow, it just perfectly nails the OS's real job. The analogy is just brilliant. An OS doesn't create resources. It's more like a vulture. It's a master of managing what's already there. It takes the hardware it's given, your CPU, your memory, your storage, and it expertly carves them up, allocating those finite pieces to all the hungry applications that are screaming for them. So we've talked theory. Now what if you wanted to get your hands really dirty? I mean, what if you wanted to understand every single nut and bolt of your operating system? Well, you could build it yourself. Welcome, my friends, to the insane world of Linux from scratch. Now look. The whole point of LFS isn't to build your next daily use operating system. No way. Think of it as an educational pilgrimage. You are compiling every single piece from its source code, the compiler, the command line, the kernel itself. And by doing that, you gain this deep, almost primal understanding of how all the pieces of a modern OS actually click together. And let me tell you, the process is, well, it's intense. You start by creating this little isolated sandbox so you don't accidentally wreck your main computer. From there, you build, by hand, the tools you need to build other tools. You install the absolute bare essentials like a command prompt. Then you write the very scripts that will bring your system to life at boot up. And for the grand finale, you compile your very own Linux kernel, customized just for you. And to give you a sense of the sheer effort here, we're talking over 50 standard build units. An SBU is basically the time it takes to compile one specific core package. So, yeah, this isn't exactly a weekend project. It's a serious commitment that shows you just how much complexity we all take for granted every single day. All right, I want you to take a deep breath because we're about to make a massive jump up the stack. We're going from the most manual, down-in-the-weeds process you can imagine all the way up to the highest level of abstraction, the cloud. This is a world where the physical computer is almost completely invisible. One of the big ideas in this space is the hybrid cloud. The goal here, with something like Azure Stack, is consistency. It basically lets you run a mini version of the public cloud, but on your own computers, in your own building. You get to use all the same cool cloud tools, but with the control and privacy of having it all on-premise. Now, this is where it gets really wild. In the cloud, even the network, the network, becomes software. A VPC, or virtual private cloud, is like getting your own private walled-off slice of a massive public cloud like AWS. You decide how the network is laid out. You control the traffic rules. You set up the firewalls. It's like having a whole data center network that you can design and change with just a few clicks. Okay, so we've got our virtual infrastructure, but now how do we get our apps onto it?
And, more importantly, how do we do it quickly, safely, and without breaking things for our users? This brings us to our final layer of abstraction, the world of continuous deployment.
This right here, this is the secret sauce behind how your favorite apps get updated almost constantly, sometimes without you even noticing. The second a developer saves a new piece of code, it triggers a fully automated chain reaction. The code gets built, it gets pummeled with tests to make sure it's not broken, and if everything looks good, it gets deployed out to real users, all without a single human having to press a deploy button. So how do you actually pull this off? Swap out the engine of a plane while it's in flight? Well, there are two main tricks. In a blue-green deployment, you have two identical setups. You deploy the new code to the idle one, the green one, and once it's ready, you just flip a switch, and all the traffic instantly goes to the new version. Canary releasing is a bit more careful. You roll out the new code to a tiny fraction of your users, your canaries in the coal mine, and you watch them closely. If nothing blows up, you gradually roll it out to everyone else. And of course, none of this happens by magic. It's all powered by a whole ecosystem of tools working together. You've got Git to manage the code, and platforms like Azure DevOps to organize the entire pipeline. But the real glue is in the automation tools, little triggers called Git hooks that can kick off the whole process, and deployment engines like Kudu that handle the final step of getting the code onto the servers.
Okay, we have gone from the absolute guts of the operating system all the way up to the highest peaks of cloud automation. So now let's connect all the dots and see the full picture.
So here's the missing piece. How does a simple app, just running along in what's called user space, talk to the super powerful privileged kernel we started this whole journey with? The answer is the system call. It's the official, secure bridge between those two worlds. When your app needs to do something important, like open a file or use the network, it can't do it directly. It has to politely ask the kernel by making a system call. The kernel does the heavy lifting and then hands the result back. It's the critical handshake that links everything together.
So when you put it all together, this is the stack we just climbed. We started down at layer 1, the kernel, the ultimate manager of hardware. Then we saw at layer 2 what it takes to actually assemble that system by hand. We leaped up to layer 3, the cloud, which takes an entire data center and turns it into software. And we finished at layer 4, with the automated pipelines that deliver our applications onto all of that infrastructure. You can see how each layer is built on the power and abstraction of the one below it. So, I want to leave you with this question. After peeling back all these layers, from the intricate dance of the kernel to the mind-boggling scale of cloud automation, which part gets you the most excited? Is it the low-level, hands-on control? Is it the grand, high-level architecture? Or maybe it's the automation that ties it all together? Whatever it is, you now have a map to start exploring. Thanks so much for joining me.